Morning, everybody. If you can go ahead and give me a green check in chat and let me know you're with me, and we'll get started here in a second. I wanted to spend a little bit of time kind of recapping what we went through 2 classes ago, because last day we just went over a bunch of information from the previous 3 units. So I just want to get through a little bit of Unit 4 stuff, and then I'll spend the last maybe half of the class going over any questions you might have in regards to the midterm or anything like that. So, see a few people still waiting on check marks. The end of the reviews is factoring. Did we learn that? No. It's a good question. When we talked about the learning guide, I think I said to do the midterm review, I should say. I forget how many pages. I think it was the first 6 pages. We haven't done any factoring stuff yet, and we won't get to that until drawing algebra tiles. Use the algebra method, solve polynomials 6. Yeah, so the last 2 pages, page 7 and 8, those are both factoring pages, and we won't have that on the midterm. So we're doing pages 1 to 6 for midterm review. Is anything in Unit 4 due for the term cutoff? No. If you wanted to do some of the quizzes from Unit 4, they may come onto your first term report card, but as I've said a few times, they don't really count for very much, so it's not going to really affect your grade at all. And if it were to affect it, the difference between a letter grade, I would go back and reconsider it or look at taking it off for now, or whatever the case may be. But again, it's only 0.3% of your grade is each quiz. So the Unit 4 quizzes, even if you've attempted some of them, they'll show up on your first term report card, but it won't really affect your grade either way, just because they count for so little. So the big sort of mark things would be the Unit 4 learning guide and the Unit 4 test, which we haven't got to yet. So I just want to get through a little bit of, finish off the lesson 4 that we started 2 days ago. And then at the end of the block or class, I'll answer any questions you guys have. So I know you guys probably have a bunch of questions for the review. So I'll try to maybe power through this a little bit quick, and then you guys will have more time for questions. So hopefully that'll work. I'm just going to clear these out. Okay, so if we jump back to Unit 4, Lesson 4, it started off with, it was a bit of a long one. Unit 4, Lesson 4, factoring polynomials. So we talked a little bit about factoring, what factoring meant, prime factorization. We discussed all these vocabulary terms, and we'll talk a little bit about some of them today, but nothing super important there that you wouldn't otherwise know. So when we talked about the factors of things, we said, okay, what numbers can we multiply together to give us the number that we originally started with? So we did an example with 3,300 here, and we said, okay, we can break it down. We use a factor tree, and then on the other side here, we did just kind of prime division. So, take 3,300 divided by 2 and keep going until you end up with just a prime number at the very end. So that's what factoring was, just breaking down a number. So we're going to talk a little bit more about that today. We talked about prime factors. We looked at the greatest common factor of 126 and 144. And we're going to go ahead and kind of use this process today, but we're going to throw a bit of a spin on it. We're going to put in some variables instead of just having numbers. So the process is the same. We're going to take a number or a term and break it down into all of its parts. And then we're going to look at what parts are common to both. So let's just jump right to here. When we write a polynomial as a product of factors, we factor the polynomial. So we're going to spend some time talking about factoring. So in arithmetic, so if we were dealing with just numbers, if we had 4 and 7, we multiply those together. That would be a product, multiplication product, both the same thing. 4 times 7 gives us 28. And then if we were to ask to do the exact same thing, except factoring it, we'd say, what numbers multiply together to give us 28? And there's lots of different ways you could write it, but essentially I'm just going to write 4 times 7, because 4 and 7 together give me 28. And multiplication and factoring are just simply opposites of one another. So if I say multiply something, that's like expanding. There's lots of different words we use to represent multiplication. If I say factor something, it's just, okay, it's the opposite. Instead of multiply, I'm kind of working backwards. How did I get that 28? Well, I could multiply 4 and 7 together to give me that 28. So that's just simply dealing with numbers. What if we start doing this process with variables and letters and things like that? So algebra, essentially. If I said expand, we spent a lot of time talking about expanding the distributive principle. We're going to multiply everything outside of the brackets by everything inside of the brackets. So 3 times 2 gives us 6, and 3 times 5a gives us negative 15a, because it's negative. All right, so that was multiplication or expanding using the distributive principle. Down below it says factor. So if we think about the opposite of multiplying, over here we had this 28, and then we broke the 28 into 4 and 7, and 4 and 7 together gave me 28. So just kind of working backwards. Same thing here. The 6a minus 15a is what I'm starting with. I'm saying, okay, I got to work backwards. What did I multiply by to end up there? So it's the same thing as what we've done up above. If I have a 3 on the outside, 2 minus 5a, basically both terms here, the 6 and the 15, contain a 3. And if I pull the 3 out of each of those, I'm left with 3 times 2 minus 5a, which is what I originally started with up at the top here. So factoring is the opposite of multiplication. This is kind of where the factoring sort of idea gets a little bit tricky. So we'll look at a couple different ways to do it. But I really think it's important that when we start getting to really complicated factoring questions, if you just refer back to this chart here and just think of a really basic example, the one that we've included here, 4 times 7 gives me 28. Okay, if I need to factor 28, it's just going to be 4 and 7. Same over here. If I have 3 times 2 minus 5a, that gives me 6 minus 15a. Lost an a when I'm erased. Okay, if I needed to factor that, I'd say, what's common to 6 and 15? Well, that's a 3. So I'd pull a 3 out, and I'd be left with the exact same thing that I started with up here. So hopefully we don't lose sight of what this whole factoring thing's about, because it can get somewhat tricky, but really it's just we're doing the opposite of multiplication. So let's look at a couple examples, and then we will hopefully understand this really well. The first method here is algebra tiles. So if you love algebra tiles, I've left you some space to go ahead and use them. You can draw them in, show how those work right there. So I'm not going to use the algebra tiles right now because I don't like algebra tiles very much, but I will use the greatest common factor method. So I'm just going to rewrite the question here because I can't see it on my screen. I have 3g plus 6, and then over on this side I have 8d plus 12d squared. So these are sort of the questions that I'm starting with. So the first one in the method 2, first column here, 3g plus 6. I need to think about the terms that I'm dealing with here. So what I'm going to do is I'm going to factor each term. And what do I mean by that? Well, I have 3g and I have 6. Now, if we had a big number like the example we did above was 3,300, we used a big factor tree to break it down into its prime factorization. The numbers and variables that we deal with in these types of questions will generally be a bit smaller. So we don't really, well, we can, if you want to write a big factor tree, you can. But usually you can just look at them and visually kind of inspect them and say, okay, well, 3g, its factors are, and then write them down. So what two things make up 3g? Remember, this is multiplication. There's no addition or subtraction or anything between these two terms. So if I take a 3 and multiply it by a g, I get 3g. I've just broken it down into its factors. Can I break it down any farther? No, 3 is prime and g is a variable, so I don't know exactly what that is. What about the 6? How do I end up getting 6? What's the prime factorization of 6? If I multiply 3 by 2, I should end up with 6. Are there any ways, other ways to end up with 6? No, I think that's the only way we can get 6. So there we go. So I've factored each term in my binomial. I have the 3g and I have the 6, and I factor them both. And now I need to say, okay, what is the greatest common factor? The greatest common factor between these two things. We wrote that as the GCF. What is it? What do both of these things share? Both terms. If I look really carefully, I see that they both have a 3 in them. So do they both share a g? Nope, only my first one has a g. How about the 2? Do both terms have a 2? Nope, only the first one has a 2, or the second has a 2. So the greatest common factor is just going to be 3. All right. So if I have 3g plus 6, I know that's equal to the greatest common factor, which is 3. What did I leave behind in my first term? So if I look at my first term here is 3g. I pull a 3 out of there. What am I left with? Well, I'm left with a g. So here's the g that I'm going to include. And here, I pull a 3 out. I'm left with plus 2. So what I've done is I've just pulled out a 3 because the 3 was common. It was the greatest common factor between my two terms. I can pull it out and then just write it as a multiplication. Remember, factoring is the opposite of multiplication. I have to end up at the same spot I started with. It just looks different. So this is how I write it. I just write it as 3 times g plus 2. And that is that factored. So that was kind of a straightforward example. Maybe let's look at the second one here. I have 8d and I have 12d squared. So if I wanted to factor 8d, what terms do I have that I multiply together to end up with 8 and d? Well, it's just 8 times d. And then 12d squared is maybe a bit trickier. I need to think of the prime factorization of 12. So 12 is going to be, you could write like a factor tree over here if you wanted. You could go 3 times 4, and 4 is 2 and 2. You don't have to if you can just kind of, look at it and say, okay, 2 times 2 is 4 times 3 is 12. I should do the same thing with 8. 8 is going to be 4 and 2, and 8 is 2 and 2. So instead of writing 8d, I'm going to write it as 2 times 2 times 2 times d. That's better. It's prime factorization of that. To get 12, I'm going to multiply 2 times 2 times 3. And then to get d squared, I would multiply d by d. So those are my prime factorizations of those two things. I need to think now, what is the greatest common factor of these two things? What is shared by both of them? They both have to have these things. So I see that I have a 2 here and a 2 here. So that's common. I also have a 2 here and a 2 here. That's common. I have a 2 here, but I've run out of 2's in my 12d squared, so that doesn't work. And then on the bottom here, I have this 3, but I don't have the 3 up on the top, so I can't say that that's common. But then I get to the d. I see I have 1d here and 1d here. So I have a 2, I have another 2, and I have a d. So I could write this as 2 times 2 times d, which is just the same thing as 4 times d. That is the greatest common factor. Both of those terms have a 4d in them. That's the biggest thing that goes into both. This is maybe where it gets a little bit tricky. So I'm just going to rewrite it. 8d plus 12d squared equals. What was my greatest common factor? Well, that was 4d. In my first term here, this 8d, what did I leave after I pulled out a 4d? What was left? If I look at what was left, I see that I have this little 2 left. I didn't use the 2. So I'm going to rewrite the 2 down below in the first term, and then I had my second term. What didn't I use in my second term? I had this 3, and I have this d. So I'm going to write those down below as well. 3d. Now the beautiful thing about factoring is when we get to the end and we factored it, we end up with this 4d times 2 plus 3d. We can always check to make sure our answer is right. And checking is just expanding it. We just multiply it out to see if we did it right. So the next page has this check on it, but I'm just going to show you right here. Here's our check. So 4d, 2 plus 3d. Does it work out? I multiply this and that. So 4d times 2 is 8d. 4 times 3 is 12. And then d and d is d squared. Is that what I started with? Did I start with 8d plus 12 d squared? I did. So it looks like I did it right. Now, this is only kind of the first times you're seeing this sort of thing, so I'd imagine if you're somewhat confused now, that's okay. It's all right. It'll come after some time, so we'll spend some time looking at a bunch of examples. Hopefully it'll make more sense as we get a little bit further into it. Again, the next 2 questions, you have the option to use algebra tiles. I don't really like how that turned out, but oh well, a little formatting error there. So you get to read vertically. Note when a polynomial has negative terms or 3 terms, we cannot remove a common factor by arranging the tiles as a rectangle. Instead, we sometimes arrange them in tiles into equal groups. And this note is why I dislike using algebra tiles for this particular section. Because it doesn't work. And that's kind of why it's silly, I think. But anyways, they say you should know how to do it, so good luck. Let's look at the same sort of question here with a trinomial instead of a binomial. So we have 6 minus 12z and then plus 18z squared. And then we also have 5 minus 10a. That's 5a squared. All right, the first term here we have 6. What is my prime factorization of 6 going to look like? That's going to be 2 times 3. Then we have negative 12z, or just 12z. We'll just maybe ignore the negative for now. 12 we just talked about. If we go 2 times 2 is 4, times 3 gives us 12, and then we have a z. If we look at 18, we break it into maybe 9 and 2, which is 3 and 3 and 2. So if I wanted to break 18 down, I go 2 times 3 times 3. In this case, it's z squared, so I have 2 z's. So that is breaking all of these things down into their prime factors. Now I need to ask myself, what is common? What is the greatest common factor of these things? So I see that there's 1, 2 here. This one has a 2, this one has a 2. So they all have at least 1, 2. What else do they all have? Well, this one has a 3, this one has a 3, this one has a 3. And then anything else? Well, I have 1, 2 here, but they don't all have 2 2s, so I can't use that 2. I have an additional 3 here, but they don't all have that, so I can't use that. These second ones both have z's, but I don't have a z in my first term. So it looks like my greatest common factor is just 2 times 3, which is equal to 6. So if I were to rewrite this, I don't know if I'm going to have enough room here. 6 minus, this was my original equation, 6 minus 12 z plus 18z squared. I know my greatest common factor is 6. What was left in the first term after I pulled out a 6? Well, both terms I pulled out, so what's really there? If I had a 6 and I divided a 6 out, I'd be left with just 1. That's where this gets a little bit tricky, I guess. If there's nothing there, we don't represent it as 0, we represent it as 1. And the reason we use 1 is because that needs to be a placeholder for that first term. When we check here, you'll see what I mean in a second. If I'm talking about the 12z, I see that I have a 2 left and a z. So that's a negative 2z because I had this negative sign here. Subtract it. Then my last term was positive, so I'm going to add it. What was left there? See that I have a 3, a z, and a z. So 3z squared. So I guess the tricky part here is there's kind of two things. If you've never seen a question like this before, you had to watch your signs, because once we pull out that second term was negative 12, and we needed to kind of maintain the negative in that second term. And then if we pull out the 2 and the 3 out of the first term, we need to hold its place with a 1. Down below here in a second, we're going to expand, and we'll see what that looks like. So maybe I'll do the second part of this, the 5 minus 10a minus 5a squared, and then after I've done that, I can go and check. I'll check them both at the bottom. Wouldn't the greatest common factor just be 3? Well, when we say the word common, Taylor, we see that the 2 is also common to all of them. So each one of these terms has a 2 in it. So that would be part of the greatest common factor. They also all have a 3. So those are the two things that are common to them. Okay, 5, 10a, and 5a squared. Again, we're just going to have to mind our signs for now. 5 just breaks down into 5. There's nothing I can break that down into further. It is prime. 10, I can break into 2 times 5, and then I have an a kicking around there. And then here again, I have 5 and a and a. I guess I've been putting these things in brackets, so I'll just continue to do that. There you go. So now we need to say, okay, what's common to all of these things? What do they all have? Well, I can see this one has a 5, this one has a 5, this one has a 5. Essentially, my first term has nothing else in it, so I nothing else is going to be common to these things because the first term only has the one thing. So if I were to rewrite it, I could write it, I guess I should write down my greatest common factor. What is that? It's just 5. So I can rewrite it as 5 minus 10a minus 5a squared is equal to, I pulled out a 5, and what's left in my first term? Well, again, I have nothing there, so it's just a 1. How about my second term? What's left here? I see I have a 2 and I have an a, so I'm going to write this as minus 2a because of the negative sign here. And then here I have this minus again, and I see that I have a times a, which is going to give me a squared. Looks like I lost my little note onto the next page, so I'll just leave that for now. So it's important, once you're finished factoring, check your solution. We can do this by expanding. Because expanding is the opposite of multiplication. So expand and multiply are the same. Factoring and multiplication are kind of opposites. So I'm just going to scroll back up here, and in this big white empty space, I'm going to do a check. Do my check. So I have 6 times 1 minus 2z plus 3z squared. If I expand, I'm going to multiply the 6 by each term inside the bracket and see if I ended up at the same spot I started. So I end up with 6 times 1 is 6. 6 times negative 2 is negative 12. And then 6 times 3 is 18 z squared. Is that what I started with? It looks like it is. So I know that I factored that correctly. On the other example here, I had 5 times 1 minus 2a minus a squared. If I were to expand this and multiply each of these things out, and I'd get 5 minus 10a minus 5a squared. Is that what I started with? It sure is. So I know I've done that one correctly. Could you show us how to do with algebra tiles, because it's in the questions and I don't know how to do it? Yes, Abby, I will show you how to do with algebra tiles, but not today. Maybe on Tuesday's class we'll have some time to do that. It's really one of these things that isn't terribly important, and if I waste a bunch of time on it, I'd feel really bad. If you know how to factor, that's the important thing. Using algebra tiles is about the least of our worries at this point. So I'll spend maybe a bit of time on it. The midterm won't have anything. I don't think there's any algebra tiles in the test bank. I haven't seen anything come up yet, so you should be okay. Like I said, maybe only once or twice have I seen questions with algebra tiles on the exam, provincial, and even then it's, you can solve them without using the algebra tiles. So it's there, I have to mention it, but it's not really worth spending a ton of time on. So maybe the next class, I'll see if I can find some time to talk about algebra tiles. And honestly, they don't really work that well for this sort of thing, so I think it's just a waste of time. But you asked, I will see if I can find some to deal with that. The last example here we're going to get to for today is factoring polynomials with more than one variable. So the questions we've done thus far had an a and some numbers, or a b and a bunch of numbers. So this one has x's and y's. which makes it a little bit trickier. But if you kind of follow the process I outlined here, it'll work for you. Now, I should mention that generally speaking, when we factor numbers like we're doing right now, we don't generally show the prime factorization of all of the things. What I would typically do with a question like 3 here is I'd say, okay, what's common to all of these? Well, I'd see that I have x cubed here, an x here, and an x squared. So what is the biggest x I have? Well, they all share at least one x. So you don't need to even write this down, but just showing you my thinking. They all share an x. How about the terms out front? 12, 20, and 16. What is common to 12, 20, and 16? What is the greatest common factor of those things? If I think really hard, I think, oh, well, 12 and 16, those both have a 4. 20 also has a 4 that can come out of there. What about 6? No. So I'd probably pull out a 4, and then I have a y squared, and a y squared. So the largest y would just be y. So that would likely be my greatest common factor. So when I kind of do it this kind of brute force method, I would look at it and say, okay, if I pulled out a 4xy, if I started with a 12 and I pulled out a 4, what's left? Well, I know 4 times 3 is going to give me 12. And then I have x cubed y, so if I had x squared times the x, that would work. And then do the same thing with the next term. What do I have to multiply 4 by to get 20? Well, I'd multiply it by 5. And then I have xy here out front, so I'd have to multiply this by just a y. And then 4 times negative 4 gives me the 16. I have x squared y squared, so I'd have xy. So once you get good at factoring, you can do problems just like that. You could pull out a negative 4, and we'll talk about that in a second. That'll change all of my signs to positive, which is kind of nice. So that's completely acceptable. And that's even what the note says here on the side. Usually speaking, we don't have a negative in front of the first term. So we'll pull out a negative at the end if we need. This is how, moving forward, once you kind of get the hang of these type of questions, you'll be able to just do them kind of in one step. There's lots of opportunity to make a mistake when you do it that way, but that's just generally speaking how the questions are done. So I'll do it the method I've been showing you just to be consistent, but we'll eventually end up just doing it like this with, I guess it's just kind of like a brute force method where you're just writing everything, doing it all in one step. Alex, I saw you pull in a question here. If it tells us to factor completely, but the number is 24, 8 to the power of 6, do we have to write out 6 times, or can we just put 2 times 2 times 2 times 3 and 8 to the power of 6? For the way we've been doing it, if we're looking at what's common and we're circling the common things, it makes more sense to write that a out 6 times. I don't think that I would, maybe let's say this. If you kind of understood what I did up here, Alex, where I was just, doing it all in one step, this sort of thing, then showing that a 6 times isn't extremely important. So for the beginning, when you're first doing this stuff, if you want to show this greatest common factor method that I'm about to do, that's fine. Once we get some practice and you get into it a bit more and you just want to show it all in one step like this, I don't mind that. That's just how you'll do these questions eventually. But at this point, it's kind of important to understand the why behind the how it's kind of being done, if that makes any sense. So let's look at our terms here. Let's look at the method we've been doing. I'm just going to clean this up. So what we're going to do to start is we're going to factor each term. Now the process is exactly the same as what we've been doing. I'm just going to forget the negative 12 for right now. I'm just going to write it as positive 12, x cubed y. What are the factors of 12x cubed y? How do we get the prime factorization of that thing? So we have this 12. If we want to write a factor tree, we can. We can break 12 into 4 and 3, and 12 is 2 times 2 times 3. There we go. So 2 times 2 times 3 is 12. And then I have x cubed. So if I want to break down my x cubed, I'm going to have 1x, 2x, 3x, and then I have a y. So 12x cubed y. Its prime factorization looks like 2 times 2 times 3 times x times x times x times y. That's how we break it down. The next one is 20, and again, we're just going to ignore the negative for right now, xy squared. Okay, 20 is going to be 5 and 4 is 2 and 2. So if I go 2 times 2, 5 is prime, and then I have 1x, and then I have y squared. So 1y, 2y's. And then we have 16x squared y squared. 16, breaking that one down into its prime factors. 16 is 4 and 4, which is going to be 2 times 2 times 2 times 2. So there's 1, 2. So there's my 16. And then I have x squared. There's 1x, there's 2 x's, and then I have y squared. There's 1y, there's 2y. So I've done all three of my terms. Now I need to find my greatest common factor. What is it? What is common to all of these things? What do all of them have? They all have a 2. There we go. We know we have that 2. Do they all carry a second 2? There's 1, 2. There's 2 2's. Yep, they all have a second 2. The 16 down below here is a couple extra 2's, but the ones above don't share that, so we're not going to include that. Do they all have a 5? No, none of them have a 5 other than the middle one. What about x's? I see that this one has 1x here. This one has 1x here. This one has 1x here. What about y's? Do they all have a y? Yes, they do. This guy has a y. This guy has a y. This guy has a y. Did I miss anything that was common to all of them? Is there anything else there that is all three of them have? I see I have some extra x's up in my first term here. That I don't have here, so I can't include that. So it looks like it's 2 times 2 times x times y. So when I write down my greatest common factor, they all have a 1, 2, they all have 2 2's, they all have an x, and they all have a y. 2 times 2 times x times y. So what is 2 times 2 times x times y? Well, 2 times 2 is 4. And then x and y I can't combine any further. So my greatest common factor is going to be 4xy. So that's kind of breaking all these terms down, looking at what's common to all of them. And when I did it up above here at the top, I have this negative 4xy, and that is the exact same thing I got here, except for that negative sign. So just looking at it and determining what was common, I ended up at the same spot I did when I broke down all the factors and wrote them as prime factorizations. So a couple more points about this question. There's the note over here on the side. When we factor a polynomial that has negative terms, we usually ensure that the first term inside the brackets is not negative. So in order to do this, we can remove a factor of negative 1 from everything. And essentially by pulling out a negative 1, it's just going to flip the signs of everything. And I think Abby mentioned that before. About the negative 4. Yes, she did. So let's maybe look at what this is going to look like. I had my greatest common factor of 4xy. And then I have my 3 terms inside my bracket. 1, 2, and 3. Now I'm saying that this first term, we don't like it when it's negative. It's just kind of one of these math faux pas things, where it's just generally not nice to write the first thing as being negative. So if we pull out a -1, I could write a -1 here, or I could just multiply the -1 and this 4 together and just end up with simply a -4xy. It's going to make my first term here positive, which is what I'm hoping to end up with. So let's do that. I'm going to pull out that negative as well, just so I can make the math gods happy and have that positive first term. So if I look at, sorry, jumped a little too far there. If I look at my first term, I pulled out a greatest common factor. What's left? Well, I have a 3 here, I have an x, and I have another x. So what's left in that first term? 3 times x should give me 3x squared. It started out as a negative, but now that I have my negative outside, it's now become positive because I have to flip all my signs. The next one here, my 20xy squared, I see that I have this 5 and I have a y. Again, it started out negative, but now I have a negative out front, it will become positive. So I have positive 5y. In my last, my 16x squared y squared, I see that I'm left with a 2, an x, and a y. So 2 times 2 gives me 4. X times y just gives me xy. And again, it was negative, but now it becomes positive. All right, what did I start with? Well, I started with -12 x cubed y minus 20 x y squared minus 16 x squared y squared. So what I want to do is I want to check to see if my answer is correct. So I'm just going to rewrite everything here. -4xy, 3x squared plus 5y plus 4xy. I'm going to expand. That is what checking really means. Just expand and multiply this out 3 times. So -4 times +3 is -12. X times x squared is x cubed. And then I have the y kicking around. My next term is -4 times +5, which gives me -20. I just have an x, and then I have y times y, which gives me y squared. My last term is -4 times -4 times +4, -16. X times x is x squared, y times y is y squared. Is this the same as what I started with? It sure is. You probably could have ended up with 4xy on the outside, -3x squared, minus 5y minus 4xy. And you can see that this answer is very similar to this answer here, but my signs are flipped. So that kind of goes back to the idea that, generally speaking, in mathematics, having this first term being negative is kind of not something we typically would do. So if you got this, the answer would be completely right. You've done everything right if you got to this spot. But on a multiple choice test, like the provincial exam, you're not going to see an answer that looks like this guy because this first term is almost always written as a positive. So what you need to do is say, all right, if I pulled out a -1, that would change all of these signs. So negative becomes a positive, negative becomes a positive, and a negative becomes a positive. And now your first term is positive, that answer is likely the one that will appear on a test. So that's just kind of the catch, I guess, with these types of questions. And again, if I just wanted to change the signs of all these things, I could just put this as positive and change these back to negative. It just changes everything inside the brackets. Now, I'm just going to take a little peek at the learning guide to see how much we've covered now. And then I'll go over any questions you guys might have. We do have about half an hour for questions, which should be lots of time. So I'm looking at page number 9 now. Factors and multiples, we're good to go with that because this is just breaking things down into their common factors. List the prime factors only. Write the following numbers as a product of primes. So we're good with all this stuff now. So this is page 9. List the prime factors, find the least common multiple, Factoring polynomials. You should be, I'm going to leave C, well, I'll write a little star beside C. This is kind of a bit of a tricky one. If you can get it, awesome. If you can't, I'll explain it a little bit once we get some more time here moving forward. So you should be able to do A, B, and D there. Factoring simple trinomials. This is where we're up to. So really only about 3 or 4 questions to do. So this is the end of lesson 4 here. At just before factoring simple trinomials. So you should be able to do everything up to that point. Factoring simple trinomials is the last little bit here. It gets a little bit more complicated, but really we only have a couple lessons left. I think there's maybe 2 lessons left. The next lesson we do is kind of, the lesson for, I would say even Math 10. It's maybe kind of the biggest sort of concept you learn in Math 10. So I didn't want to do it until after the midterm so you guys can focus on the midterm, kind of maybe absorb a little bit this Unit 4 stuff as you're focusing on that midterm, and then moving forward in Unit 4, we'll kind of take all of the stuff we've done so far, put it together in the next lesson, and we should be okay. So that's all I wanted to say about Unit 4. We have about 25 minutes or 20 minutes for you guys to ask any questions. Now, Alex, I know you asked a question about something at the very beginning of the block, and I didn't get to go over it. But if you want to just type it in again, I apologize for making you type it out twice, but it'll be faster than me trying to scroll through chat to find what it was. Unit 4 algebra tiles number 3. Taylor, I'll talk about, I covered it. Thanks, Alex. I'll talk about algebra tiles maybe next day or the following day on like Tuesday or Wednesday next week. Don't focus on this algebra tile stuff, guys. I know it's in there because it just needs to be, but it's nothing that is super important. And if you don't understand it, it's not a bad thing. It's okay to not get algebra tiles. If you do understand it, perfect. But don't stress out about algebra tiles. It's not worth the effort. From the midterm review, can we go over question 3B, page 6, and 8B on page 2, question 9 on page 4? Yes, definitely. Anything from Unit 4 or the midterm review, I would be happy to go through. Midterm review, page 6, 3B. There's page 6, 3B, page 8A, page 2. And question 9, page 4. Draw a diagram of composite shape. Okay. And then Unit 4, page 8, question 4E. So Ava, I'll grab that Unit 4 stuff here in a second. I'll go through this unit review stuff first. So simplify and leave it in simplest radical form. Okay. So we have 44A 5b cubed. We need to maybe look at this 44. So leaving in simplest radical form means, are there any perfect squares that go into 44? I would break this 44 into 4 and 11. Then I have a to the 5b cubed. I'll write it as root 4 times root 11 a5b cubed. And this is 2 11 a5b cubed. Now, when we have a variable under a radical sign like this, I assume they've simplified the a's and b's as well. If I rewrote this as 2 times 11 a to the 5b cubed, all to the power of 1/2, because that's the same thing, how can we simplify the a5b cubed? I don't know if they've written as exponential powers or if they've just left it this way. So maybe I'll just, if somebody wants to just type into chat how they've written the answer with a radical or with a fraction, that would help me moving forward here. Should be 2, probably root 11. I don't know what they've done with the a's and the b's. I would be happy with that. I have a feeling they haven't written it that way though. So I guess the important bit here is that you can simplify the 4. Writing it like that is good. Just can't really simplify it a lot further than that. So, I mean, you could, go a to the 5 over 2 and b to the 3 over 2. But I doubt they've done that. So if we can get that far, that would be just splendid. So that's the first one. 2a11 squared aab. 2a, ooh, that's confusing. They pulled out the a. Okay, so that's what I'm kind of afraid of. What they've done is they've said, okay, this is 2 times 11, or 2 times root 11, and then they said a squared and a to the 3, and they've said b squared and b to the 3, kind of like that. And then they say, okay, what is the square root of a squared? Well, that's just a, so there's 2a. And what is the square root of b squared? Well, that's just b. And then you're left with 11a. Sorry, this should be b. Left with 11a b. Like that. So they've just broken the a and the b down. Didn't do a ton of questions like that. I don't even think there was a question like that in the learning guide, but that's what they're doing. They're taking the square root, and if we look at it in terms of this fractional exponent type of thing, we could have a to the 2, a to the 3, because together those give me 5, 2 over 2, 3 over 2, because we have this 1/2 out front, b to the 2 over 2, and b to the 1 over 2. A to the 2 over 2 just gives me a, b to the 2 over 2 just gives me b, a cubed, b 1/2 is another way of looking at it. And then you put these back under the radical sign if you want. So you can break them down further into 2's and 1's and then end up here. And then we have the same thing here with this a to the 3. We can break it into a squared times a, And then we can take the square root of a squared, which is just a. So we have 2ab times a, or 2a squared b times the square root of 11ab. So that's kind of the long and the short of getting those variables simplified. Maybe I'll look at b here real quick. I'll do it over on the left. Gives me some room because it's the same idea. So 12 is 4 and 3. So this is going to be 2 root 3 is 12. Square root of 12 is the same thing as 2 root 3. And then we have a to the 6, which is like a to the 6 over 2, and b to the 7 over 2. So we have 2 root 3, a to the 3, b to the 7 over 2, that's maybe not the easiest way to look at that. The a works out nicely because it 6 and 2 gives us the 3, but the b to the 7 over 2, we can write it as, maybe I'll back up. So 2 root 3 is the 12. We're happy with that. And then we have a squared times a squared times a to the 1. And then we have, sorry, that's a to the 6. A squared 3 times. And then we have b, run out of room again, b squared times b squared is 2, 2. Another b squared is 6 times b to the 1. So this is all under my square root still. So we have 2 root 3. Square root of a squared is a, square root of a squared is a, square root of a squared is a. So this is a times a times a. And then my b's, I have b, there's another b, and then I have the square root of b. So I get 2a cubed b cubed root 3b, which is the long and the short of it. So hopefully that makes a little bit of sense. I don't know why it didn't come up in the learning guide. Oh, I didn't tell you to do it in the learning guide. That's the problem. It did. It was number 8 in the learning guide from that unit, and I said, don't do it, because we hadn't done fractional exponents yet, so it didn't really make a ton of sense. It might still not make a ton of sense. Jade had one more question, I think, or somebody did, with fractional exponents. Try valuing these without a calculator. Does the exponent here, 3 over 2, have a negative sign in front of it, or is it just positive? I have a box. I'm not sure what the box is representing. I'll assume it's positive until somebody tells me otherwise. I see 81, which is going to be, it's a negative. Okay. I see 81, which is just a perfect square, even though it's a decimal. So 0.9 times 0.9 is 0.81, which is kind of nice. This negative 3 over 2 means I'm going to flip this. So it's going to be 1 over 0.81 to the power of 3 over 2. I see the bottom here is a 2, so I know I'm going to do the square root of 0.81 cubed. And the square root of 0.81 is, it's just 81, so it's just 0.9, and then cubed. And 0.9 cubed is, 0.9 times 9 is 81 times 9. Geez, I don't know what 81 cubed is, or 81 times 9. I know it says estimate, but I'm going to have to cheat here and go 81 times 9. 729. Hopefully that helps a little bit. I think that was it for Jade's questions. I'll just scroll up here, see if I missed anything. Unit 4, page 8, question 4E. This guy here. So this is an expanding question. I guess there's lots of different ways to do it. It's going to be a bit of a messy one. I'm going to leave the 4 out front, and then I'm going to expand the x. I'm going to FOIL these guys. So I'm going to get 4x squared minus x plus x minus 1. And then I have negative 4, x plus 1, x plus 1. Something squared, I can write it out twice and multiply it. I'll simplify the x's in the middle, so I get 4 times x squared minus 1. And then I'm going to have negative 4 times x squared, foiling these guys now. X squared plus 2x. I guess I should do it in 2 steps. X plus 1. So I get 4x squared, expanding this, minus 4. And over here I get negative 4 times x squared plus 2x plus 1, combining my like terms in the middle. So 4x squared minus 4, then expand this guy out. Negative 4x squared minus 8x minus 4. Combine like terms, 4x squared minus 4x squared goes away. Negative 8x, I have negative 4, and another negative 4, negative 12. Sorry, I did it anyways. There you go. For E, can you go over question 1 and 2 and factoring simple trinomials, vocabulary stuff? Sure. Alex, is that on the learning guide or is that on the Unit 4 stuff? Shane, I was talking about a different unit when I said don't do number 8, so ignore that. Unit 4 learning guide. Did I not just mention how far we should be in the Unit 4 learning guide? Unit 4 learning guide, you should be up to factoring simple trinomials, page 10. So just before page 10, the end of page 10. So you don't have to do this stuff yet. This is lesson 5, which we haven't done. Okay, so we're not there yet. I think that might be why you're a bit confused on it, possibly. So Taylor, question number 2 on page 2, number 6D, page 2, 8F. Is that midterm review or is that Unit 4, Taylor? I'll assume midterm review until you tell me otherwise. Page 2. Number 6B and D. And there we go. All right, so simplify the following, leave in simplest radical form. I need to figure out the largest perfect square that goes into 126. So I know my perfect squares are 4, 9, 16, 25, 36, 49, 64, 81, 100, 121. So I need to figure out the biggest one of those that goes in to 126. 126 divided by 36, that doesn't work. Sorry, 126 divided by 36, that doesn't go in. 126 divided by 16 maybe, does that work? Nope. 126 divided by 9. 9 goes in there 14 times. So I'm going to just bring this up front. 3, and I'm going to break my 126 into 9 times 14. I'm going to say, okay, square root of 9 I know, which is 3. And I end up with 9 root 14. And 14 can't be simplified any further. There's no perfect squares that goes into 14 because we can get 2 and 7 out of there, and that's it. And 2 and 7, neither one of those are perfect squares. So the next one is a perfect cube one. So my perfect cubes are 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. This one might be a bit bigger one. So 6 cubed is 216. 7 cubed is 343. So I need to figure out the biggest perfect cube that goes into 648. So I just start dividing away. 648 divided by 27. That goes in there 24 times. So that isn't the biggest. 648 divided by 216, 3 times. So I'm going to break this down into 216, which is 6 cubed, times 3. 216, sorry, my cube roots I forgot. Cube root of 216 is just going to be 6 times the cube root of 3. So figuring out the perfect cube that went in there that's the largest. Now, I tried 27 and it went in, but I noticed when I divided 648 by 27, I ended up with an answer of 24. And I said, oh, 8 goes into 24, so I haven't picked the largest perfect cube at 27. 27 wouldn't have been the largest perfect cube because I can break 24 down into 8 times 3, and 24 is a perfect cube. So there's 2 perfect cubes that went in there. So if I picked 27, I would have had to do the question sort of in 2 steps. So instead of 27, I said, okay, there's a bigger one, and then 216 went in there. So that's why I picked 216 and 3. Now, thinking I'll probably leave it there for now. A couple things about Monday. Central Gym, 8F, same page. See if I have time here, Taylor. Central Gym, Monday morning. I'll be there at about 8:30 if you want to come early and have any questions, or if you want to get started on the test a bit early, that's fine. It's all going to be written. Sorry, you're not going to do it on a computer. I shouldn't say it's all written. There'll be 25 multiple choice questions and 5 written questions. Multiple choice, you'll just have to circle the answer. The written questions, you'll have to show some work. What else? You don't need to bring anything. I'll have formula sheets for everyone. I will also have scrap paper and things like that. You can write right on the test. Yeah, Taylor, because you're in Vancouver, yours is digital. Everybody else will be just doing it kind of out by hand. So what you do need to bring is a pencil or a pen and a calculator, and that's essentially it. Bring yourself. If you want to bring a snack or something, that's fine. Do we need to show any work for multiple choice? No. I'm just going to mark the solution that you have circled. So if you want to show a bunch of work, you can write right all over the test. It's fine. I'm not going to use them again. And then that's it. So Monday morning, 9 o'clock, Central Gym. I'll be there a bit early. That'll be that. My first question was this: could we look at number 2 and 3 on page 8 of Unit 4 Learning Guide? I don't need to spend a lot of time because I know some problems. I just don't have the technical terms. How long do we have the midterm? The midterm will definitely, it'll take you maybe like an hour and a half. You'll have, we've got 2 hours booked in the gym. So I don't think anyone's in after us, but I have other classes to teach that day. So you should be good till about 11:30, but I don't envision it'll take that long. Abby, I have just a couple seconds left, 2 minutes. Unit 4 Learning Guide, page 8. Question was number 2 and 3. All right, so binomial squares, that'd be like 2a plus 1 squared. That's a binomial and it's squared. You take the first term and you square it. Take the take the 2 terms in the binomial and multiply and double. Take the last term and square it. It's just a bit of a trick. Conjugates have the same terms, but different signs. Just a couple little things that will make your life easier. They don't come up that much, but if you do encounter them. So 2a plus 1, 2a minus 1, those are conjugates. Sorry, what did you say that would be at the gym for the test? The gym, bring yourself a pencil and a calculator. You should be good to go. Everything else will be there for you. No problem. If you have any questions between now and then, just email me or, message me in Moodle and I can get back to you. But that's all the time we have for today. I have another class I need to run to. So Mrs. Ward will be on, check my calendar here, in about 10 minutes or so. You need to be at the gym at least 9 o'clock. But anytime before then at 8:30 I'll be there. So if you have questions before you want to see me, 8:30 in the gym at Central. Thanks guys. We'll see you on Monday. Have a good weekend.